thought I would give a quick update on the progress I've made with this IBM 5120. If you've seen the previous videos in the series for this machine, you'll know that it was in a terrible state when I first got it. The debris in the electronics tray literally filled it right to the top of the lip. It was absolutely caked in dirt. There was corrosion everywhere, and also I didn't dare turn it on. If you go back and look at the first video in this series, you'll see the condition that it was in, and hopefully you can now see that I have made some progress. I completely dismantled the machine, stripped it down to its bare metal parts, stripped all the metal back to bare metal, recoated it all, so stripped it using a bead blaster, and then primer etched it, and put a top coat on that matched the original, and it's now starting to look quite presentable. Now unfortunately I do not own this machine, so there's only so far I can go with it, and I'm still not sure if this is going to be repairable, but I want to get it into a state where it's either working or at least in good enough condition that someone is willing to spend some time and maybe a bit of money getting it finally finished off and repaired. But I thought I'd just give an update and show how far I've got. I have reconnected everything apart from the floppy drives. I've slowly been refitting the cards into the electronics box. This is still free to slide in and out. I've got it so that I can get it to slide right the way out, and so I can do fault finding on the boards. But everything is reconnected that needs to be reconnected. I've left these accessory cables out of the way for now, but I have cleaned those. I've restored all the bracketry and everything. It's just I haven't fitted it if it's going to get in the way and isn't needed. Everything else though is installed, and I've been slowly going through and testing it. I went through the power supply as you probably saw in previous videos, and there were some question marks over it, and I was a bit concerned about some of the voltages. So what I did as a temporary measure was fit some limiting circuits to make sure that the supply voltages could not exceed a certain level. They're actually still in there, but they're not being triggered, so I don't think they're needed, but I'll leave them in for now just to be on the safe side. And there are about 6 or 7 voltage rails on this machine, and it looks like some of them need to come up in a certain order, so I didn't want to attempt to hook up external supplies. The modules on these machines are quite robust, much more robust than modern TTL, or should I say more modern TTL, but even so I don't want to risk damaging them. So when I first powered it up with all the rails active, it was completely dead. I wasn't getting any activity whatsoever in any of the cards, and so the question is how to start, because I don't have any schematics for this machine. It uses almost entirely modules, the IBM modules that you may have seen in the previous videos, so very little information about the actual circuitry and how it's supposed to operate. And so what I decided to do was to work my way back from the monitor. I know what signals the monitor requires, so I thought I'd start by trying to get the H and V sync signals up and running, and they come back through a cable, it's this cable, to this connector, and then to this board. So I've started with this, and what we'll do in this video is just have a quick look, and I'll show you the basic testing that I've done and how far I've got. Everything else seems to work except for this fan. There are several fans on this. You'll hear them when I power it up. They are quite noisy, but this one's dead, doesn't work. There is power going to it, it just doesn't spin, so I suspect the fan has failed, but for test purposes it doesn't matter. So what I'll do, I'll get it powered up, and we'll just have a quick look at the supply voltages. The easiest place to measure the voltages is actually on this interface board, so I'll relocate the camera so you can see the connections coming from the power cable, which is this one, and then we'll just do a quick test on supply voltages with it powered up and running, so you can see that they are sitting within the allowable limits. So looking in the left hand side of the machine, we have this intermediate signal distribution board. This is really the interface board and card between the main system and the floppy drive. So that one of the two floppy drives plugs into two identical interface boards, and this in turn sits on a small motherboard. So this end connector, the one nearest the back of the machine, is the main power feed for the system. So this comes directly from the power supply, and it has several connections for each of the main power rails. This thing down here is just some protection for some bits that normally bolt to the rear cover, but I don't want them shorting out, so I've just wrapped them in some towel for now. So what we'll do is get the test meter, and I'll power the machine up. It is quite noisy, as I said. The internal fan does run, and it is quite loud. So hopefully you can still hear me. And I'll reference everything to chassis. That's what everything seems to be referenced to. And then if I go through the various power connectors, we should see the various supply rails. So the first one is the 5-volt rail. It's at 4.9 volts, which is fine. The first four are the same. We have a minus 5 volt rail, which is sitting at minus 5.2, which again is fine. 8.5 volts, and again that's fine. And then finally a 12 volt rail. It's a bit high, but it is specified as being up to 13.5 volts, so again that's fine as well, and they are quite stable. I have tried varying the mains voltage, and that all seems to be doing exactly what I would expect it to. So what we'll do now is get the scope up, and we'll have a look at the signals going to the CRT. Okay, I've got the scope hooked up. It's referencing the chassis as ground, and what we'll do now is we'll look at the signals coming out of the ribbon cable that goes to the CRT display. This is the only part of the circuit really I've done much work on. I have done some investigative work on the other cards, but so far this is the only one I've really spent much time working on. So the first connection we'll look at, this should be the vertical sync pulses. So we should have 60 Hertz negative going sync pulses on this connector, and as you can see that's exactly what we have. It's nice and stable, exactly as we'd expect it to be. And the next connection is the horizontal sync, so this will be 15 or 16 kilohertz. So it's shown as 15.72 kilohertz and nice and stable, so that looks fine as well. Now unfortunately the next one should have the video information on it, and while it does have a small DC voltage and maybe a bit of information in the background, it's hard to say. There seems to be something going on, but there's nothing of any significance there, and it doesn't make any difference if I press any keys or press the reset. That's as far as it's getting. So the next step really is to start to investigate the processor circuits. I'll start with the reset circuits and then work my way through looking at the memory and see how far I can get. Now I suspect I won't be able to get this fully up and running unless I can find some documentation for it, but I will post regular updates. As I said, it's not my machine, so I can only spend limited time on it. Haven't given up yet, but we'll see how far we can get. Just for completeness, I'll spin the unit around and we'll have a look at the front, and you'll see what's currently showing on the display. So as you can see, the front of the machine is in much better condition than it was. I've given it all a really good clean. I've done a bit of restoration on some of the damage to the plastic, but it's generally speaking in very good condition. Obviously I've taken all the controls out and cleaned those. I've taken the tube out and given that a good clean. It wasn't too bad. I'll power it up again. And as you can see, we are getting something on the screen. It needs adjusting for width, but at least it is scanning the screen and the frequencies are correct, but there is no information, and also we're not getting any retrace suppression, so there's something odd going on there. There's obviously no real video information. If you're seeing flickering on the camera, that's not visible in real life, that's just an artifact of the camera shutter speed. But as you can see, none of the controls do anything other than restart, which does actually light the in process LED. So it does appear that there is some activity going on in the processor system. It doesn't make any difference what we try to display, we're getting exactly the same. So what I need to do now is trace this restart back and see what it's trying to do, and try and figure out why there's no activity in the rest of the system. Very slow process without schematics or any real technical information, but I'll see how far I can get. Any feedback or information would be most welcome. If you've ever worked on one of these, or if you have any documentation for one of these, I'd really appreciate anything that you can assist with. So that's it for this video. Like I said, it was just a quick update, just to let you know I'm still working on this. I haven't given up just yet, and I've got some interesting projects coming up shortly.